Hello everyone, my name is Tule, and today I and Dongfang will present our paper about uncovering Lenient skill vetting process and protecting user privacy at runtime. So our project focused on smart home environment, which is the most common scenario for IoT applications, and voice interactions play an important role in this smart home setup, which allows the user to control the appliances and devices at home using their voice through the smart speakers. So our project focused on the smart speakers and their voice applications, specifically the Alexa platform, which is one of the most popular platforms. So from now on, I will refer to voice applications as skills. So the motivations, we lack understanding of the entire ecosystem. Although there are many privacy risks that were identified in previous work, the specific root causes of these issues are still underexplored. We don't have enough platform protections from the service providers themselves. That leads to the need for effective defense mechanisms. Prior work actually proposed some skill vetting techniques. However, they rely on manual efforts, which is not efficient. So when a skill gets published to the market, it will go through a skill certification process that determines if the skill meets the requirements or not. If it doesn't, then feedback will be given to the developer for further development. So what could go wrong with this vetting pipeline? Previous work showed that they're violating skills that ask for personal information without declaring any permissions. However, we show that permission might not be the only problem here. To test the hypothesis, we implemented our test skills with permission. And there are two versions that we tested. In the first version, we make the functionality of the skill match with the permission requested, meaning that if we request for phone number, then we use it in the functionality of the skills, and it passed the certification process in the first round. However, in the second version, we have the functionality that didn't match with the permission, then in this case, our skill got rejected. And this is a feedback from the vetting process. However, as we know that the skill can be hosted on the third-party server instead of Amazon server, we actually update our server-side code for the skill to change the functionality after the skill get certified. And our skill actually survived for several days after it got taken down. So this is a gap of several days that a malicious skill can be on the market. So with this result, we actually found that there's actually another monitoring process after the skill gets published. And this is supposed to continuously check the skill to make sure that it remains a good skill. However, there's some problem with this monitoring process as we reverse engineer it. So the limitations are, first of all, it's not actually continuous as it's supposed to be. And we figure this out by logging the coming request from Amazon to our skills backend. And we showed that in our paper. So because of the not continuous problem, we found a way to bypass the monitoring process uh, by programming our skills to only activate the data collection during certain times. And the second problem of the monitoring process is that it doesn't cover a complete intent invocation paths of the skill, which allow us to inject our data collection behavior under specific user interaction that could be missed by the vetting process. So to show the impacts of these problems in real world, we look into the user reviews for the skills to understand if the user experienced such problems. And we found that some user actually complain about the behavior change of the skills that they're using. So the problems are first, the dynamic behaviors of the skill. It is unpredictable. And the second thing is that there are third-party updates that is not controlled by Amazon because the skill can be hosted on a third-party server. So next, Dongfang will present our solutions to these problems.
Hello everyone, my name is Dongfang Zhao. I will introduce our runtime monitoring system protecting the user privacy. The idea is to add an extra layer between user and the skill to review every response from the skill. For each response, the system will analyze those skills' response asking for user information. Only if the requested info has correlation with the skill functionalities, it is determined as harmless. A crucial part of our system is the skill behavior consistency check. It assesses the alignment between a skill's information request and its declared functionalities. So here we notice that we have to manage to determine the relationship between skill response asking for user info and the skill functionalities. We employ textual entailment to resolve the challenge. Textual entailment is used to determine if the meaning of one text can be inferred from another text. Essentially, it involves evaluating whether a hypothesis is likely to be true given a premise. Here we use skill description as premise, reflecting the skill functionalities, and use the response asking for user information as the hypothesis. And any misalignment flags the skill as suspicious. This slide shows the Alexa workflow. We propose to integrate the runtime monitoring system directly into the Alexa service module. This ensures every user utterance and skill response will be evaluated for privacy concerns by our solution, detecting any dubious requests for personal information. But in fact, we are not able to do that for the Amazon Cloud service. So instead, we implemented a prototype on the local machine. And now let's take a look at the components inside our skill behavior check module. Its first step involves the question extraction, identifying responses requesting personal information. Then these requests will be vetted against the skill's permission list. The presence refers to compliance and no malicious intent. The absence, however, flags the skill as potentially suspicious, prompting a consistency check to assess the request's relevance to the skill's functions. The orange line refers to skill information request which has no correlation with its functionalities. That means the skill is suspicious. Analyzing the Amazon skill store with our skill behavior check module, we identified 637 skills asking for user info with explicit utterance during the user interaction, in which 141 skills are suspicious. They do not have a permission list set up for the requested information, and the request is not related to their declared functionalities. To showcase our proposed solution is not only effective but also efficient, we conducted an in-person user study. We leveraged open source Alexa voice service, which is called AVS, to implement and test our runtime monitoring approach. We instrumented AVS with our skill monitoring design on an Ubuntu machine. Our user study divided participants into two groups. One interacted with standard AVS system and the other with our enhanced system. Feedback indicated our solution was both effective and efficient, without introducing noticeable delays. In conclusion, our research highlights the limitations within the Alexa skill ecosystem. Given that developers can alter their skills backend logic at any time, we introduced a runtime monitoring solution. This method continuously evaluates skill behaviors during user interactions, ensuring they align with the skill's intended functionalities. Leveraging our consistency check module, we were able to evaluate the skill store. And based on our implemented prototype, we conducted a user study demonstrating its effectiveness and efficiency. So thank you for engaging with our presentation. We are glad to share our work on user privacy and security in the voice personal assistant platforms. We look forward to making further contributions in this area. Thank you.